pacemaker is usually considered as an artificial heart. It is of two types, internal pacemaker, external pacemaker. This project deals with the wireless secured pacemaker using a parallel processor. In a normal pacemaker, it consists of a normal embedded. When the normal embedded fails, the pulses won't reach the human heart, thereby leading to the death of the patient. But in a secure pacemaker, it consists of a secure embedded and also a normal embedded. So, when normal embedded fails, secure embedded sends the pulses to the heart instead of normal embedded, thereby saving the patient's life and also indicating to the nearby healthcare stating that the normal embedded has failed using a transmitter. In our project, we have used normal embedded and also secured embedded. Equipments used for making the kit are 4 astable multi-vibrators, signal conditioner, filter banks, normal embedded, secured embedded, transmitter, receiver, transformers. The filter banks are actually inbuilt to the signal conditioner. Working of the kit. 4 astable multi-vibrators produce the same pulse rate given out by a human heart. Since we cannot use a human heart for our experiment, we are using these 4 astable multi-vibrators. The pulses produced by these multi-vibrators are then transferred to the signal conditioner board. Electricity is used to turn on the kit. Since resistors and capacitors are placed on the signal conditioner board, a little amount of current will be generated. When these pulses cross them, their amplitude might change. To avoid such circumstances, zeros or spans are placed so that the amplitude of the pulse would not change. Later, amplification will take place. That is, the amplitude of the pulse is later compared to the threshold value of the human heart. If the value is low, that is, if the amplitude is low, the pulses are amplified and are sent to the filter bank. Normally, our internal organs produce various sounds. To remove these sounds, filter banks are used. Therefore, the filtered pulses are transmitted to the normal embedded. If the normal embedded works properly, the pulses get transmitted to the heart. In case if normal embedded fails, secured embedded starts working and transfer the filtered pulses to the heart. At the same time, the signals are transmitted using a transmitter to the nearby hospital stating that the normal embedded has failed. We are using an indicator in order to know which embedded will be working. Now, since normal embedded is working, these set of LED lights are being lightened up. Now, let's press the reset button so that the secured embedded will be working. Now, to know that secured embedded is working, these set of LED lights are getting lightened up thereby stating that the secured embedded is working. We are using transformers to generate electric current. Wait. Pulses produced by 4 astable multi-vibrators can be considered as PQRS. If any of these pulses are not produced, it is notified to the nearby hospital. Now, since all the waves are produced in our experiment, these LED lights are getting lightened up. Now, let's press the reset button so that the secured embedded will get working. Now, see, when you press the reset button, the receiver are not showing any it is showing a lot of difference. That is, it is not showing the lights getting turned up. That is because the secured embedded lot of thing is that you can see that these LED lights are not getting turned up. Therefore, it is notified to the hospital that the normal embedded has stopped working and the secured embedded has started working. Hope you have gained enough knowledge from this experiment. Thank you.